Hi students, in this video we are going to find the inverse of a matrix by Gauss Jordan method. Given find the inverse of the matrix by Gauss Jordan method, let us take the given matrix to be is equal to A, where A is equal to 2 minus 1, 5 minus 2 first sum. We are going to augment this matrix along with the identity matrix. A matrix is of order 2, so the augment matrix also we take the identity matrix of order 2, which is equal to, we write the elements of the A matrix and combine the identity matrix along with this matrix. Now we make the elementary row operation. Our aim is to bring the first element, the A matrix, the place of the first A matrix, to bring the, we make the elementary row operation, bring the given equivalent matrix to the identity matrix, and the elements of the next matrix will be the A inverse matrix. This is our aim. So the first elements of the A matrix, let us bring these elements to to the identity matrix, that is 1, 0, 0, 1. So the first row, we know the first element is 2. So I divide the first row by 2. So this matrix is being transformed to R1. I am changing to R1 to R1 by 2. Divide the elements of the first row by 2. We get 1 minus 1 by 2, 1 by 2 and 0. The second row elements remains the same. Next, my aim is to bring this element, A21 element to 0. So what we do here is R2 tends to R2 minus 5 times of R1. And so this becomes, the first row remains as it is. The second row, 5 minus 5 becomes 0. Minus 2 minus 5 into minus 1 by 2 gives me is equal to 1 by 2. So this element is 1 by 2. This is 5 into 1 by 2 gives me minus 5 by 2. 1 minus 5 into 0 gives me 1 here. So we have written the elements. We have got here A1 element to be 1, A21 element to be 0. So our aim is to bring this element to 0 and this element to 1 here. So the next transformation, what we are going to do, I am going to change R2, multiply R2 by 2. Since the elements are all divided by 2, I multiply the given element by 2 elements of the second row. The first row remains as it is. Second row multiply by 2, it becomes 0. 1 minus 5, 1 into 2 gives me 2 here. Next I am going to change R1 to R1 plus 1 by 2 times of R2. I want to bring this element to 0. So here we make the transformation. It becomes 1, 0, minus 2 and 1. Second row remains the same, minus 5 and 2. Now this matrix so formed is of the form I and A inverse. The matrix, after giving elementary transformation, the matrix so formed from this equivalent matrix, we take it as, so we get A inverse is equal to minus 2, 1, minus 5 and 2. This is the X minus 2, minus 3. Along with this, the identity matrix 1, 0, 0, 0, 1, 0 and 0, 0, 1. Now the transformation, what I am going to do here, I am going to change here R2 minus of R1. I am going to subtract the first row and the second row here. Both the rows we are going to make the subtraction. We are going to subtract both the rows here. So the elements so obtained will be is equal to, so R2 we are changing to R2 minus R1. So the matrix so formed will be 1 minus 1. The first row will remain as it is, 1 minus 1, 0, 1, 0, 0. Second row 1 minus 1, 0. 0 minus of minus 1 plus 1 minus 1, 0 minus 1 is minus 1, 1 minus 0 is 1. The next element is 0 minus 1 is 0. So the last row remains the same, 6 minus 2 minus 3, 0, 0 and 1. Next we are going to make the transformation again here. So the transformation what we are going to do is R2, I am going to change R3 here. I want to bring this element to 0. So I change R3 here, R3 minus 6 times of R1. So R1 and R2 remains the same, 0, 1, 0, 0. Second row remains the same, 1, minus 1, minus 1, 1, 0. The third row, I'm going to make the transformation with the first row, taking the first row multiplied by 6. The first row elements are multiplied by 6 and are being subtracted. So here the transformation becomes, the first element becomes in the third row 0. The next element becomes minus 2, minus of minus 6 into 1. So gives me 4 here. The next element is minus 3, 0, minus 6 into 1 gives us 6 here. 0 minus 6 into 1 gives us minus 6 here. Next element is 0, next element is 1. Next transformation we are going to do with R3 here. The element is 4 here. So we make the next transformation with R3. So next R3 tends to R3 minus 4 times of R2. R1, R2 remains the same. We write the elements as it is. 0, 1, minus 1, minus 1, 1, 0. Now I am going to make the transformation R3 with R2, taking R3 minus, multiply this second row, multiply the second row with 4, and we are going to subtract. So the elements so formed will be 0, 0. The next element minus 3 plus 4 gives me 1. Next element minus 6 plus 4 gives me minus 2. The next element is minus 4 and the next element is 1. Next transformation, what we can do here is, I'm going to change R1 plus R2. I'm going to add R1 and R2 to bring this element to 0. So R1, 1 plus 0, these two, the first row and the second row both are being added here. So this is 1, 0, minus 1, 0, 1, 0 plus 1 gives me 0 here. So R1 plus R2 we have added, second row remains the same, the third row remains the same, minus 4, 1. The next transformation, what we are going to do here is, next I am going to add R1 to R1 plus R3. When we add R1 and R3, this element we can bring this element to 0. Our aim is to bring the first set of elements of the matrix to in the identity matrix form. So R1 plus R3 gives me 1 plus 0, 0 plus 0 is 0, minus 1 plus 1 gives me 0. The next element is minus 2, 1, minus 4, 1 plus of minus 4 gives me minus 3. Next element is 1. The second row remains as it is. Third row remains as it is. Now we see that we have to transform only these two elements, where our aim is to bring only this element to 0 now. So what is the transformation we can do here? We can add R2 and R3 here. So the next transformation we are going to do, change R2 to R2 plus R3. So the matrix so formed will 1, 0, 0, minus 2, minus 3, 1. Now adding R2 and R3, 0, 1, 0, minus 1, minus 2 gives us minus 3, 1 minus 4 gives us minus 3, and the next element is 1. The last row remains the same. Now we see that the matrix is of the form I and A inverse. So from this equivalent matrix we can write A inverse matrix. This is the A inverse matrix, and therefore we can write A inverse is equal to minus 2, minus 3, 1, minus 3, minus 3, 1, minus 2, minus 4, 1. Moving on to the third sum, we have the A matrix. We write the augment matrix. combining with the identity matrix of order 3, and this will be is equal to 1, 2, 3, 2, 5, 3, 1, 0, 8, 1, 0, 0, 0, 1, 0 and 0, 0, 1. So now I'm going to make the transformation R2 to R2 minus 2 times of R1. So R1 remains the same, 1, 2, 3, 1, 0, 0. Now we are going to multiply the first row with the 2. I'm going to multiply the first row with the 2 and then subtract with the second row. So 2 minus 2 gives me 0. 5 minus 4 is 1. 3 minus of 6 gives me minus 3. The next element 1 minus 2 gives me minus 2. Next is 1. Next element is 0. So the last row I'm going to change here R3. R3 tends to R3 minus R1. Now we are going to subtract R3 and R1. So 1 minus 1, 0, 0 minus 2, 8 minus 3, 5, 0 minus 1 is minus 1, 0, 1 minus 0 gives me 1 here. The next transformation, what we are going to do is, I'm going to add R1 and R3. Our aim is to bring this element to 0. So we are adding R1 to R1 plus R3. So the first row elements we add with R3, 1 plus 0 is 1, 2 minus 2, 0, 3 plus 5 is 8. Next element is 0, 0, 1. The remaining two rows we write as it is. 0, minus 2, 5, minus 1, 0 and 1. The next elementary operation, what we are going to do is, I am going to change R3 to R3 plus 2 times of R1. So here we are going to change, I am going to bring this element to 0, R3 plus 2 times of R1. So R3 plus 2 times of R2. So the first row remains as it is. R3 we are going to change, so the elements of R2 also remains as it is. Now R3 becomes 0, the next element also becomes 0, then 5 minus 6 gives us minus 1, the next element is minus 5, the next element is 0, plus 2 gives us 2, the next element is 1. The next transformation what we are going to do is, R1 we are going to change R1 to R1 plus 8 times of R3. This element is 8, this element is minus 1. So we are going to multiply the last row with 8 and then we are going to add R1 and R3 here. So the first two elements, 1 plus 0 is 0, 0. The next element 8 minus 8 gives us 0. The next element 0 minus 5 into 8, so gives us minus 40. Next element is 16. Next element 1 plus 8 gives us 9. Next we are going to change R2. We are going to make the operation with R2 where R2 tends to R2 minus 3 times of R3. So the second row becomes 0. Next is 1. Minus 3 into 0 gives us 1. The next element becomes 0. The next element is 13. So 13 minus 2 plus 15 gives us 13. The next element is minus 5. The next element is minus 3. The last row remains as it is. Now we see in this matrix that all the elements have been transformed in the form of identity matrix except this minus 1. So what can we do here? We can multiply the last row by minus 1. So what is the next transformation we are going to do here? The next transformation is R3. R3 I'm going to multiply with minus 1. So R1 and R2 remains the same. Elements of R2 is 0, 1, 0, 13, minus 5, minus 3. Now R3 we are multiplying with minus 1, 0, 0, 1. Now it becomes 5, minus 2, minus 1. Now the equivalent matrices of the form In A inverse, and this is the A inverse matrix, and therefore we can write from this the A inverse matrices. Therefore A inverse is equal to minus 40, 16, 9, 13, minus 5. We are multiplying R3 with minus 1. So first row, second row remains the same. So here 5, minus 2, minus 1. I have multiplied the previous step R3 with minus 1, and we have got what is A inverse here.